Woodwind instruments can vary in shape and size, but they all have commonalities between them. Woodwind instruments can be divided into two separate groups: reed instruments and aerophones. In reed instruments, air is blown into a mouthpiece, which causes the reed to vibrate. This vibration causes pressure differences or sound waves inside of the instrument. The way a reed instrument can make different pitches is by releasing air through the keys. This changes the pressure inside of the instrument, which in turn changes the velocity of the sound waves. The different velocity causes the different frequencies through the equation frequency equals velocity divided by wavelength. When the more keys are pressed, the air pressure goes down, which causes the velocity to decrease and in turn causes the frequency to decrease. Larger instruments, such as the tenor saxophone, cause the wavelength to increase, which lowers the frequency. This is why the tenor saxophone sounds lower than the alto saxophone.
Brass instruments create pitch by allowing musicians to buzz into a mouthpiece, vibrating the entire horn. The pitch is created and manipulated by extending and lowering the distance of tubing which the air and the pressure travels through. Slide instruments, like the trombone scene, extend the tube by moving the slide backwards and forwards, manually changing the length required for each pitch. Valve instruments, like trumpets and French horns, create this length by activating the valves, which are all connected to set lengths of tubing. These lengths of tubing, when combined with the lengths of tubing for other valves, will create the lengths for separate pitches. When you blow the air through the horn, it creates a standing wave corresponding with the set pitch that you want to play. This can be demonstrated by the equation f of n is equal to n of v over 2l. The length of the tubing and the volume of the horn will create the pitches set by this equation.
The head of the mallet strikes the bar, which is suspended on two strings, which sets it into a rapid oscillating motion. The center of the bar vibrates up and down, and the pitch is determined by the length of the bar, or rather the wavelength, which is the distance between the two nodes. The nodes of any given bar are located at the points at which it is suspended by the string, and therefore the maximum volume and resonance will occur when the bar is hit directly between the two strings, or the two nodes, which is the antinode. The equation for the frequency of the wave of the bar's motion as it relates to the wavelength, or the length of the bar, is as follows. The sound of each bar is amplified by a resonator, a piece of metal tubing suspended below the bar whose resonant frequency is the frequency created by the bar's oscillation.
Much like a marimba, the piano works by having a small hammer strike a tuned string. The piano uses strings of varying lengths, density, diameter, and tension to create a wide range of pitches. Strings made of copper, silver, and many other materials are used to create different tonalities and pitches. The denser the string, the lower the frequency. Strings of varying lengths are also used. The shorter the string, the higher the frequency, and the longer the string, the lower the frequency. Therefore, throughout the piano you will see many different strings of varying lengths. Strings also have varying diameters. The strings with larger diameters will have lower pitches than the ones with thinner diameters. The thinner the diameter will also create a much higher pitch. You will see this also throughout the piano. For precise tunings, many piano tuners can adjust the tension inside of the strings. The tighter the tension will create higher pitches, and less tension will create lower pitch. These can all be demonstrated by the equation FO equals 1 over 2L times the square root of the stress times the tissue density.
Although there is a part of the body called the voice box, which is also known as the larynx, singing and speaking require far more than just the use of this one organ. Vocal cords, which medically speaking are actually vocal folds, are little membranes inside your neck that snap open and shut while singing, speaking, or making other noises in general. Air pressure builds up against them, and the folds snap together, and a sound is created. When they are snapped gently, you hear a soft sound. When they're snapped forcefully, you hear a loud sound. This is because the amplitude increases as the force increases between the folds. The quicker that the chords open and close against each other, the higher the resulting pitch will be, because the frequency and the pitch are actually just the same thing. Vocal cords open and close 100 times per second during normal speech, which means that one is normally speaking at about 100 hertz, but this can be tripled and even quadrupled while singing.